Now let's move on to the history of navigation. So please add this to your engineering notebook. Navigation originally started out as just observation. We were just observing fixed points around us. You would drive towards a mountain or a building or close to a destination just to try to figure out where in the world you were. The setting sun indicates a westerly direction, so that was oftentimes used. So, a quick question for you: what direction does the sun set if you're in Australia, the southern hemisphere? Well, it's sets in the same place, all right? The sun still rises in the east, sets in the west. Doesn't matter if you're in the northern or southern hemisphere. Trick question, or maybe not. So you'll see the little pencil icons. It's going to help you figure out what you need to write. Maps are objects just plotted on paper to represent the Earth's surface as seen from above. They have these imaginary lines called latitude and longitude. And latitude lines run east and west. And they measure north and south distances. But latitude is flatitude because it's flat. Those are the flat lines that run east to west, whereas longitude run north to south and they measure east to west distances. But longitude lines run north and south, flatitude lines are flat. And there you go, some lines of latitude, lines of longitude. A little picture for yourself. So you could even draw yourself a little sketch if you want. Your compass. A compass is a magnetized piece of iron that aligns Earth's magnetic field. I don't have a pencil icon here, so just listen in. The magnet points to magnetic north. It is not the same as true north, and so there is a deviation. And when you are navigating, you have to take into account that deviation. It can be a few degrees difference as you are navigating, and it's something that's important for pilots especially. So here we have a little magnet with some iron things, and there's the Earth magnetic field. It has a bit of a slant to it. It's not direct true north, so it's going to be off a little bit as you, depending on where you are on the globe. Ocean passage, they used to use this method called dead reckoning, and it used time and velocity. So please note that. The idea, the words dead reckoning, some people believe it came from deduced reckoning, or if you didn't follow it, you would be dead. There's a lot of different ideas about where the origins came from, but they used this tool called a sextant, and it measured angular altitude of stars above the horizon. And then they would have this little log dragging behind the boat to indicate a speed. And so this is how they used to measure their position and their passage in the ocean back before they had more modern tools. We have now these things called towers that would give these beacons that would allow aircraft to travel from point to point, and they would navigate by sight using these little revolving airway beacons, and then they could travel from coast to coast. They had routes set up using these towers, and it was basically line of sight from tower to tower. But then you'd have clouds and dust and haze and things that would obscure vision, so they needed a lot more um, like they needed a lot more cutting edge type of radio navigation. And so now we have that. We have these things like a DME, don't write these down yet, a LORAN, ILS, VOR, NDB, and GPS. We're going to go through each one of these six individually. Let's start with DME. Write that down, please. It stands for Distance Measuring Equipment. And this measures the slant range distance. I want you to take a minute and draw this picture out because what you are going to notice is that the airplane in this position measures a distance of 20 nautical miles. That is a slant distance from the plane to the station. Its true horizontal distance is only 19.9 nautical miles, which is almost the same. So that DME is pretty good when you're really far away. But as you get right over the top of it, you are actually 0 nautical miles from it. However, it still reads 1.2 because that is the distance that your plane actually is from this thing. There is no diagonal distance anymore. It's just the height in this case. And then if we continue on, if we get to, at this point, we're 4.8 nautical miles away, that slant height is 5 nautical miles. Then we're getting to a more reasonable measurement. So it's not an exact, but it does get you a reasonable measurement as long as you are far enough away from it. As you get right over the top of it, it only is giving you your altitude. It's not giving you this hypotenuse distance here. You also have LORAN. This is called long range navigation. This was typically designed for maritime navigation. Their range for each station is fairly wide reaching, and it was just a supplement to aerial navigation. Next one is ILS. Please write that down. Instrument Landing System. This is a navigation aid to guide runway or to guide aircraft onto a runway. They use two different things: a localizer, which is the altitude adjustment, and then a glide slope, which is your left to right. and you're going to use this piece of equipment in your cockpit to be able to identify if you need to go left, right, up, or down on this glide slope using the ILS. So this is something that we hope to get you practice on when you're using your flight simulator, where you are landing just using this tool, and maybe you are even doing it in the dark so you can't even see the runway, and we'll see if you can land it appropriately using an ILS system, or at least get yourself close. Then we go to VOR, which stands for Very High Frequency Omnidirectional Range Radio. It just rolls right off the tongue. This is a older type of navigational system. It uses this radio beacon that sends out these signals in every direction, and there are VOR lines, these VOR frequencies that are at every single angle here, every single degree from 0 to 360 degrees. You can tune your VOR to those particular VOR stations, and it will tell you if which degree that you are on. So if your airplane is flying and you're over here on this 90-degree line, and you tune this thing to 90 degrees, which would be 090, it would actually be turning this dial so the 9 is all the way up on the top here, then our little vertical line here is going to be pointing straight up and down. More on that later on. That was probably something that didn't make a whole lot of sense unless you're currently a pilot. But you'll get a little bit more practice with how we tune the VOR station so that we can use this little arrow here to tell us, are we on the line, or do we need to go left to get on the line, or right to get on the line? It does show its position relative to the VOR, and it is commonly used, but more frequently they're using a GPS. So let's get to non-directional beacon. A non-directional beacon just measures the clockwise angle between the airplane longitudinal direction and the NDB. It's one of the oldest electronic navigations used. It can be used at a lower altitude than VOR. That is one of the downsides to VOR. And let me go back to this. Go back to your VOR notes right now. And I want you to write down that you cannot actually tune to a VOR unless you reach a minimum altitude. Kind of depends on where you're at and where the VOR station is. But your beacon in the airplane may not pick up that frequency on the ground. It may, but it may not. So there are some that have a minimum altitude. So you just want to write there is a potential minimum altitude for VOR usage. And let's see, the aircraft instrument for this is called the Automatic Direction Finder, the ADF. We're not going to get into that one so much, but I do want you to talk here a little bit about GPS. I want to note this. It provides three-dimensional locations. So that's where the pencil is. That's what you should write down. It gives you latitude, longitude, and altitude, plus a timestamp. So all of those things can give us a lot more exact position depending on how many GPS satellites that we are communicating with. And more on that a little bit later when we get into GPS. The components involved are satellites orbiting Earth. You have control and monitoring stations on Earth, and you have GPS receivers that are owned by the users and installed into aircraft. And that is it for this. Great job.